y3 since y2 is occupied, thank you, and put in a what? As a matter of fact, at the same time, let's go back up to y1. No, don't delete. You see where the equal sign is? If you move your cursor over the equal sign, you can toggle it on and off with the enter button. Notice now that it's no longer lit up. If it's not lit up, it won't graph. So that way I have my linear model still in there, but I don't have to be burdened with looking at it. And where's my 50s?
It's the bottom horizontal.
Oh. Okay, there. I'm good, fine. It looks like the graph, sorry, I'm just being silly. Let me take that back off for a second here. Okay. There's just the exponential. Look at that, beautiful. It's perfect. And then y equals, put in a 50 here. Let's see, we have, yeah, there comes a 50. So right there, we have second, calculate the intersection, number 5. Move over there. All right, so 5.299. So what do you suppose the half-life of this stuff is? 5.299 years? That's right.
What was that?
So we'd have to turn that into years, wouldn't we? 52 weeks. Yeah, I'm not going to do all these unit conversions. I'm not even going to ask you a half-life question. I'm going to ask you to find the value of x when y equals a particular value, and to find the value of y when x equals a particular value. Yes.
How would you write the equation for the curve?
Oh, that's a good point. A good question. Take a look when you do second quit. It tells you right here. Always before it gives you the values, and I know you don't have the r's, it tells you y equals a times b to the x. Fill in this value for a and this value for b. That's it. Or if you had to, you could always look at y equals where it's done that for you.
That's what I was.
Same, whatever, same thing, isn't it?
Do you just leave it as x, the exponent?
Yeah. Yes.
And are you going to call it the equation the model?
Yes. The equation is the model. So the word model means the equation. Yes, sir.
So does that represent, or does that answer the question for C? Does it ask for a different form of the equation?
Exactly, good question, and it does in our case. We can turn that into this, again, another class. The goal of this is for you guys to use your calculator to model data. We're using the algebra part of a statistics class. And see, you know, math is stats and math, but they do cross over here and there. So when you guys are in a stats class and you see this type of behavior, I don't want you going, I've never seen anything that goes like that, when yes you have. It's quadratic or cubic or something. That's the algebra part, okay? They do cross over. So that's what my goal is. What we can do with regression and how good one model is versus another, I mean, that is an entire course. We don't have that kind of time, nor is the class designed to cover that material. I just want you guys to see where you could use your algebra in the stats class. All right, so I will post the answers to this on my door and on the internet. Should I send around an attendance form? Oops. You need your attendance. Graph, right? See nothing. What should have we done here? Zoom 9 would be better, right? Because Zoom 9 will do actually a lot for us. Almost seems like we're getting away with murder here because it is going to the x values, finding the minimum and maximum and making the window that for you and doing the exact same thing with the y values, all in the push of a button. several things happen. Is we actually get the max and min on our window, and it does it for us. So zoom 9. Okay. So has everybody got this scatter plot? You've already got the line through it. It's okay. You got the scatter plot. That's fine. I don't mind jumping ahead. Now this is a point here where you have to determine what kind of regression you think, and we'll come up with some parameters as to what is better than not others. But just right now, from your point of view, does this thing look linear? And let's talk about the context of the problem. Children, as they grow, their head sizes generally do what? Grow right along with it at some related rate. Apparently, this youngster here, or short person here, we don't know how old they are, has a big fat head. But that's okay. There's some other issues here we need to concern ourselves with. We also know that as age continues, growth actually slows down and comes to a stop. So you see, by context of the problem, if it were me, I wouldn't necessarily say this was linear. I'd say it looked more like grow real quick and then level off. What does that look like to you from the library functions? The square root function, right? You guys say, yes, I know my library functions, I studied it. One of the requirements of college algebra, by the way, is that when you leave here and go to whatever else you go to in this world, if somebody asks you what a cubic function looks like, you better show them. Otherwise, I failed you, okay? You need to know that a cubic looks like this, quadratic looks like this, square root function looks like that. Remember all those things we talked about? Don't lose that. You'll need that again for a lot of reasons. Biology, chemistry, physics, of course, algebra. But we're not going to work with any fancy regressions today. We're still going to put a line through this. And the line of best fit, I'm going to say, would probably be something like this, trying to make it fit as best I can. Let's go ahead and see what the calculator says it is. The calculator is going to make the one that has the closest to every point possible. Okay, so how do we do this again? Second quit. If you don't want to look at what you did before, you can always clear the screen. That's no big deal. That's where clear comes in. Don't use clear to stop running anything. Clear is only to actually clear the screen, so be careful with the clear button. All right, stats where everything's happened, we're going to calculate, and again, we're going to run the linear regression, even though we could argue it's not the right one here. We're going to still use it. And where do I want to put it? Variables over to y variables, function y1. So that, maybe I should go slower. You should have the stat over to calculate to get the lid reg, then hit variables, go over to y variables, choose function y1. Running this thing does a couple things for us. First of all, it gives you the slope. Remember, it's ax plus b. We're used to mx plus b, but you can get over that real fast, and a is m, right? This is the slope. It's 0.373. I have it written here. And the y-intercept is 7.33. I have that written here. You could manually go punch that into y1 now, right? And maybe we'll punch it into y2 just to see. But what the calculator did was take all the decimal places that it has and put that into y equals. By the way, you see the r's that I have here that you don't? I can show you how to turn those on, but this r says, well, what is this? 0.80 for r squared? I would say this is a very, not so good of a match. Only 80% accurate, yes. All right.
Do I need those R's?
No, you don't need these R's. These R's are, I'm probably going to turn mine off. That's just a thing to turn on. Okay, so go look at y equals, there it is, and hit graph, and you'll see this line, the best fit, pretty much the line that I was trying to draw. And as far as at the smaller level,